VORs have been the backbone of our air navigation system since the 1950s. GPS is replacing much of the navigational coverage provided by VORs, but in the unlikely event of a GPS system failure, it will probably be VORs, maybe followed by an ILS, that will get you safely back on the ground. So you can expect that VORs will be an important part of the National Airspace System for a long time. So you'll want to know about their capabilities and limitations. The first limitation is that VORs are ground-based rather than space-based. GPS waypoints are, of course, based on satellites, and it costs virtually nothing to create a new GPS position. On the other hand, ground-based VOR stations require an investment for both the installation and maintenance of every single one of them. Since VORs sit on the ground and their signals are line of sight due to the curvature of the Earth, as aircraft get further and further away from the station, they have to be higher and higher to receive a usable signal. This lower airplane cannot receive either VOR A or B because at that altitude, the curvature of the Earth prevents the line-of-sight signals from reaching it. Because of this limitation and the limitations of signal strength, they publish a usable service volume of a VOR defined by altitude and distance from the VOR. So what is known as a standard service volume defines airspace that a VOR reliably serves. There are three types of VORs, each with a different standard service volume. These three types of VORs are high altitude, low altitude, and terminal. This is the Air Navigation Radio Aids legend from your Legends and Figures on the main menu of the course. You see a graphical depiction of the service volumes in these cylinders of airspace. High-altitude VORs are used for jet routes and have the greatest service volume. From 1,000 feet up to 14,500 feet above the station, the VOR signal range is 40 nautical miles. From 14,500 feet to 18,000 feet, the range is 100 miles, and from 18,000 feet to 45,000 feet, the signal range is 130 miles, and from 45,000 feet to 60,000 feet above the station, the range drops back down to 100 nautical miles. If you pass over a VOR 60,000 feet above it, by the way, you're also just over 11 miles above it. Here on the upper right is a service volume of a low-altitude VOR designed for Victor Airways for use up to, but not including, 18,000 feet. Up to 18,000 feet, it has a range of 40 nautical miles and isn't designed for use any higher. Here in the bottom middle is the service volume of a terminal VOR, which is mainly used for instrument approaches. Because terminal VORs are mainly used for approach procedures and not often on airways, they're lower powered and have a range of 25 nautical miles from 1,000 feet up to 12,000 feet above ground level. You can use the chart supplement to figure out the maximum range of a VOR at a particular altitude. Let's suppose that you need to find the maximum service volume distance for the Medford VORTAC OED at 8,000 feet. If you see a question like this on your knowledge test, you'll be referred to a page from the chart supplement. The first thing you need to know is what class of VORTAC is Medford. Is it terminal, is it low altitude, or is it high altitude? So we take a look down at the radio aids to navigation section. There is the Medford VORTAC, frequency 113.6, and it's an H class or high altitude VORTAC. You do not have to memorize the service volume diagram to know how far you can be from that station at 8,000 feet and still get reliable navigation coverage. During your test, you can refer to the chart supplement legend found in Legends and Figures. You'll want to remember that this legend is also found at the beginning of the chart supplements. In the Legends and Figures, there's several pages of chart supplement legends. Just go through them until you find this table. The left column is the class, the middle column is the altitude, and the right-hand column will tell us the distance, the usable service volume. Now, we've determined that Medford is an H-class high-altitude VOR. We come to the middle column for altitudes, and our altitude of 8,000 feet is between 1,000 and 14,500 feet. When you come over to the right, it will tell us the distance that we can use that station, and it's 40 nautical miles. So because Medford is a high-altitude VOR, and since we're at 8,000 feet, we'll have a usable distance from Medford VOR of 40 nautical miles. While we're looking at this table, let me ask you an interesting question. Let's assume that you're flying IFR off airways. Below 18,000 feet, how far apart can the VOR nav aids you're flying between be? Well, it depends on the kind of VORs you're using. If you're using low-altitude VORs, as you can see, they have a range of 40 nautical miles, so the greatest distance they could be apart is 80 miles. On the other hand, if you're using high-altitude VORs between 14,500 feet and 18,000 feet, they have a range of 100 nautical miles, so they could be 200 miles apart. Now, en route IFR charts do not tell you which VORs are low altitude and which are high altitude. There are no H's or L's in the identification boxes on the chart. But en route charts do tell you which VORs are terminal VORs with a 25 nautical mile service volume. The information box for the VOR DME on the field at Tyler, Texas has the letter T in parentheses to tell you that it is a terminal VOR DME. The only way you would know which VORs are high altitude with a 100 nautical mile service volume above 14,500 feet is to look right here at the appropriate chart supplement.